So near the surface of the Earth, we've been using a value of 9.8 newtons per kilogram. However, Mount Everest, one of the highest places on Earth, we might not consider that totally near the surface of the Earth, so the value might be slightly less. So this question is saying it's about 9.77 instead of 9.8. So using that fact, we're going to try to estimate the height of Mount Everest using the gravitational field formula. So that's the gravitational field formula, where r stands for the distance from the center of the Earth to the point we're looking at, which is the peak of Mount Everest. So that is going to be replaced by the radius of the Earth plus the height of Mount Everest. So that's from the ground to the top. Adding those two together, we'll get the total distance from the center of the Earth to the peak of Mount Everest. This needs to be squared as per the formula. So this is going to be rearranged for the h value. So first I'll multiply both sides by that denominator there. Then I'll divide both sides by the lowercase g. Then I will square root both sides. And then I will subtract the radius of the Earth on both sides. So now I'll fill in the values. There's a link there to some of the useful values there. So capital G would be 6.67 times 10 to the negative 11. The mass of the Earth, that's what capital M stands for, is 5.98 times 10 to the 24. We're going to use this 9.77 value for lowercase g, and we're going to subtract the whole thing by the radius of the Earth, which is 6.38 times 10 to the 6. So the significant digits is going to be tricky here, so I'm going to do this in a couple of steps. I'm going to first evaluate what's under the radical there. So I'll type in my calculator. So all that stuff under the radical, each thing there has 3 significant digits. So to 3 significant digits, it's 6.39 times 10 to the 6. Okay, so now when I subtract these, now I have to use the rule for subtraction in terms of significant digits, which is going by decimal places. So my answer is just actually going to be to this decimal place. They both go up to this decimal place times 10 to the 6. So when I subtract that, I get 0.01 times 10 to the 6. So I really just have one significant digit here. I can rewrite this as 10 to the 4, or 1 times 10 to the 4. So about 10,000 meters is the height of Mount Everest. So when I go on Google and I search for the height of Mount Everest, it's coming out as 8,849 meters. Which has 4 significant digits, but if I were to round that, I guess, to the nearest 10,000, it would be 10,000, which is the answer we got. So um, our answer is as close as possible as we can get to the correct value for the height of Mount Everest based on our significant digits rules.